So let's continue lecture 3. So this is the unit cell of face-centered cubic crystal structure, and as you can see, at every corner there is an atom, and at the center of each face of this cube there is an atom. So that's why the name face-centered cubic. So this is the heart sphere model of this crystal structure, and you can see that the atoms are touching each other along face diagonal. So this is the place where the atoms are touching each other. Similarly on that face, okay, on the top face here the atoms are touching. We saw in case of body centered cubic crystal structure that the atoms were touching each other along body diagonal. However, in case of face centered cubic crystal structure, the atoms touch each other along face diagonal. So this is the crystal structure, or this is the material, and there are several atoms, and one of the cells of FCC crystal system or FCC crystal structure is highlighted here. As this crystal structure belongs to cubic system, all the edge lengths are same, all the all the angles are right angles. Again, we want to derive the same relationship that we derived in base-centered cubic crystal structure, and this relationship is between the edge length or lattice parameter a and the atomic radius r, and this relationship is given as a is equals to 2 root 2 r. So let us derive this relationship. In this picture you can see that this is a, the edge length of the unit cell, and as you can see the atoms are touching each other along the face diagonal, and the length of the face diagonal is given by 4r, because the this length 4r can be calculated by summing the radius of this corner atom plus the diameter of the face centered atom and the radius of other corner atom. So r plus 2r plus r gives us 4r. So to derive this relationship, we are going to apply Pythagoras theorem to the right angle on any one of the 6 faces, and by applying Pythagoras theorem we get 4. In the image, capital R is used to represent the atomic radius, but we are using small r, so 4r, this should be r, small r, this should be small r, we are using small r for the atomic radius, is equals to the a square, so 4r is the hypotenuse plus the sum of squares of the length of sides. So this gives us 4r is equals to root 2a, or a is equals to 2 into 2 divided by root 2r. So we know that I can write 2 as root 2 into root 2 into 2 divided by root 2r. So this gets cancelled. So you get a is equals to 2 root 2r. So that's how this relationship is derived. In the next video, we will study hexagonal closed packed crystal system. So see you in the next video.